Yeah, comes on everyone. Let's start off. So today I'll be teaching you two different things, two different concepts which are important. But I think before that, let's do one problem from Rio Optics. Last class, May I wanted to do one more. We didn't have time. Let's see. So we have 4 points. A, B, C, and D. Getting it? So basically there are 4 points. Okay, maybe let's call them 1, 2, 3, and 4. So among them, so 3 points are on vertices of equilateral triangle. 3 points are other scans on vertices of an equilateral triangle. Point 2 is at the centroid. It's an equilateral triangle of length. Yeah, maybe you can take it as L. Okay. Now, among these 4 points, two points are objects. And the other 2 points are images of these 2 points due to a lens. Due to a single lens. Find the focal length of the lens. So we have 4 points, 3 on the vertices of equilateral triangle, 1 is at the centroid. Among these 4 points, 2 are images and 2 are objects. Which 2 are objects, which 2 are images? Nothing given. So you have to figure out which will be an object, which will be an image also. The side of the triangle is L. Just get me the main equations, okay? No need to simplify. How do you approach this? So, and where is the lens? We don't know. Where is the principal axis? We don't know. We have no idea about the lens, where it is placed, how it is placed, nothing. What is the focal length of the lens? Is the question clear? Start with this. There are 2 possibilities, isn't it? Either these 2 are objects or these 2 are objects, isn't it? Everything else will be a permutations and combinations of the same thing. Either the 2 side ka things are the objects or the one side and one vertex and one centroid is the object. Now, there are 2 possibilities. That means you can get 2 focal lengths. Because you didn't tell me which situation is what, there are 2 options, 2 possibilities. Think, take a minute or two. So I just want you to get the approach. If you got the approach, then after that it is all just lengthy calculations. Like It is just about math after that. The main idea is like, how will you figure out the position of the lens and everything? Jainil, what nonsense you're asking, God? There's a single lens and done. There are two objects, two images for a single lens. Simple thing. What is TAR and everything here? Don't mix up random things. So, how do we approach? I'll give an idea there. You think I'll give a minute after that. Listen, this thing comes from the ray diagram. If you take a lens, right, and if you take anything, see, let's say there is an object like this. So the light ray, and let's say if this is the image. So how do you draw the image? The light ray, the light ray passing through the principal axis, the optical center will be undeviated, isn't it? So the light ray which goes through the optical center will be undeviated. So basically, this is where the two light rays will meet, and that will be the image. So we need to use this funda there, like the light ray going from object to image will always pass through the optical center. If you draw a line joining the object and the image, that should pass through the optical center. That is one idea you need. Second thing, if your object is at and the image, if they're equidistant, that will happen only for one position, 2f and 2f. You know these two things, right? So if you take an object, if you take an image, and if you join them, the line joining must pass through the optical center. Second thing, if the object is at 2f, image will be at 2f. That is the only time when both are equidistant from the optical center. Now can you think of? Got the idea, right? So that properties you know. So now how do you handle? So in this 4, there are two objects and two images. We don't know who are the objects and who are the images. Equilateral triangle, side L, find the focal length using this data. Where is the lens? We don't know. Where did you keep it? Position? Nothing we know. So figuring out that is an important thing. I don't remember the answer, but it's fast aa gaya kya? Okay. Let's see. I just know it was lengthy. I just got the equations and I just left them. Ly2. Oh yeah, let's see. First of all, let's think about the possibilities, okay? Let's say this is the object. 4 points now. I'll do one thing. I'll just mark them with red, okay? Let's say this is object 1. This is object 2. So this would be image 1 and this would be image 2. Perfect. So maybe this is image 1, image 2 and image 1. Okay, doesn't matter. So first thing, the line joining the object and the image must pass through the optical center. Similarly, for O2 and I2, the line joining the thing must also pass through the center. And this is the point of intersection. And if you see, this is an equilateral triangle. So that means this position here is your optical center. Agreed? Making sense? If you join O1 and I1, that should be the line passing through optical center. O2, I2 must be line joining the optical center. Clear? And that is also an angle bisect. That is also a what you call perpendicular bisector. So these two are equal. So one thing is clear, right? And so the lens, right? That is the optical center. So the lens must be something like this. Again, remember, we don't know the exact position there. Lens will be at some random angle, right? Why it should be exactly, if it is like this, then you can't get I2, O2 like this. So lens must be something of this sort, right? And that is 1. And O1, I1 are equal. Great. And this is the principal axis. So let's say this is the principal axis. This would be at some random angle theta. We don't know that also. So basically now we have to drop a perpendicular here and drop a perpendicular here. So this is 2f now, gods. समझ में आ रहा है which is 2f? I'll just magnify the picture again. Wait. That is your principal axis. So from the object, if you drop the perpendicular, this is your O1 dash, and from the image, if you drop the perpendicular, this is your I1 dash. This length will be 2f. Agreed? From the principal axis, the length is 2f, isn't it? In this picture, is this 2f? That is not 2f, right? The base is 2f. Are you clear? And then for O2, I2 also, we had to do the same thing. For O2, I2 also, we had to drop the perpendicular, and we have to drop the perpendicular here. But this is a problem actually. This doesn't work. Any idea why this is wrong? This is wrong. Why? Look at this O2, I2 here. O2 is a real object and the image is on the same side of the lens. Matlab, this should be virtual, right? And if it's a virtual image, it should be definitely beyond the object, isn't it? Lenses में वापस जाके देखो. When you have a lens, when you had the center, when you had the focus, and when you had the pole, if you keep the object here, the light rays would go like this. The image will form behind, isn't it? The image will form behind the object. But here the image is forming between the pole and the object. You're getting it? So this case is wrong actually. This is not the scenario. The objects are not on the sides of the triangle. Clear? You're getting the catch there. So here, so for O2 and I2, right? So the image must be virtual. It is on the same side of the lens. They are on the same side. And if it is virtual, the distance OI2 must be greater than the pole PI2 must be greater than PO2. So this is a wrong scenario. This is wrong. This is the O2 is a problem. So this case doesn't work. So I think we should take the other case then. What is the other case? Object 2, image and image. The story is the same. Join this line, join this line. Now it makes sense, right? Now see, the image I2 is virtual and it is more greater than this. The picture will look the same. So this is the optical center. So the lens must be somewhat like this. This must be the principal axis. Assume this angle is theta. Then drop the perpendiculars from here. Drop the perpendiculars from here. I didn't draw it properly. This is 2f and this is 2f. Then drop the perpendicular from here and drop the perpendicular from here, and you will get the images there. You can solve. Is the process clear? So among the two possibilities, one possibility doesn't work. So there's only a single answer for this. So the main idea here is the line joining object and the image must pass through the optical center. And if you have two set of images like that, the line of point of intersection will be the optical center. That is your main idea there. Once you got that, I think everything else will fall in place. And second thing, these objects and images are not on the principal axis, they're above it. So you have to draw a random principal axis at an angle theta. तभी theta भी एक variable है. You have to derive that actually, which can be done from आ जाएगा geometry से. Clear with this? Lengthy question, but yeah, that property is pretty good. मतलब just have to think. Are you clear why the first one doesn't work, right? Yeah. That was one problem last time I wanted to show. Next thing, now there is two concepts here, okay? So one is translation and rotation. In rotation, I taught you this, but still there's a slight confusion. I'll teach you in another variation. So listen carefully. So we have done this in center of mass. First time we discussed this. What is exactly translation? What is exactly rotation? So if you take a body and if every point on the body moves in equal parallel paths, so the body is not going in a straight line, but this is pure translation. So translation is simply you can see the center of mass connotes introduction. If every point has same velocity at every point, or you can simply say every point moves in equal parallel paths. So at every point they are going the same way. This is pure translation. What is pure rotation? If every point on the body covers equal angles. This is pure rotation. Right? So that's your pure translation and pure rotation. So if I ask you this, let's say we have a, let me show you like this. Let's say we have a disk with a rod and there is a disk like this. This point here is hinged, meaning this wheel can rotate, okay? That wheel can rotate. In the second case, the same disk is there, but this is welded, meaning you're fixed. Making sense? So it's welded, it cannot rotate. It's welded, so there is no rotation about axis. You know, if I start rotating this system, if I move this system like this, what kind of motion is this? Translation or rotation? If you see the same example, right, I gave you in center of mass, I'll put that as a reference. So you should read COM page 1. The whole introduction was there only. Where is that? That's so translation motion, rotational motion, we defined this. So where are you? So the question comes, who is translation, who is rotation? Now look at the thing here, okay? When I rotate them, you will clearly see the difference. So for this hinge thing, imagine I mark 4 points, okay? Let's call this thing A, B, C, and D. Now, if I rotate this thing, see what happens. When the wheel comes here, again, I'm not drawing up to scale exactly, but yeah, here. Look at ABCD. Yeah? A is here, B is here, C is here, D is here. A is here, B is here, C is here, D is here. Did you observe something? If you just look at this line here, AC, this line AC never rotates, isn't it? And if you actually draw the paths now, you will notice A is going like this, C is going like this, the center is going. Can you see these are equal parallel paths? Every point on this thing is going in equal parallel paths. So this is pure translation. Whereas in this scenario, if you look at this, if I call this thing A, B, C, and D, and when I rotate this wheel, this is A, this is C, this is B, and this is D. This is A, this is B, this is C, and this is D. So if you look at line AC, can you see line AC is rotated? You're getting the difference here. This is pure rotation. Every point is covering equal angles. Are you clear with this? So now, suppose if they ask you time period for small oscillations, right? So you know what will be the time period for this? If I just take these two examples, now you know the time period for a physical pendulum, remember 2 pi root over I by mgd. Yeah. So we will assume this is a light rod, okay? You can assume the rod also has mass, you can play with that, but okay. I'll take the light rod ka mass also better. Let's say the rod ka mass is m and length L. This is m and r. Okay, this is m and L, and this is also m and r. So now if they ask you to find the time period of this, or maybe just let's not take it, you'll get confused. It's not a big deal, you can just add it up. ठीक है, अब इसमें moment of inertia क्या लेंगे? This is pure translation, right? So there is no rotational component. So only the center of mass is just moving. So this will have moment of inertia only ml square. You can treat every point, right, as a particle, and you can replace them at the center of mass. It's pure translation. What will be the moment of inertia of this guy? This will be ICOM plus ml square. ICOM will be mr square by 2. That is the moment of inertia about the center of mass plus ml square. So if you see the difference, right, this term is the rotational component which is missing here, isn't it? Is that making sense? The same thing, let me show it in another way. If you just see in terms of energy, you will notice this. Since this is pure rotation, if I ask you to find the kinetic energy of this system, let's say this thing is rotating with omega. So this thing, right, I can write in this form. So this idea is important because I saw, so kinetic energy of this system will be simply half I about the hinge omega square because it's pure rotation. But what is I about the hinge? ICOM plus the parallaxis theorem ml square into omega square. If you see this carefully, this can be written as m into L omega whole square plus half I com omega square. So this thing looks like half m v center of mass square plus half I com omega square. So you know what you can do for this? So when this guy is rotating, see what is happening. So this was C and this was A. This is line, right? So this is what we are assuming. So when this thing rotates, so there is the center of mass is going in a circle. The center of mass is going in a circle. Then suppose if it doesn't rotate, then the line would be like this. Then this line also is rotating in this direction so that the line AC will become here. So this is the rotation about the center of mass and this is the rotation of center of mass. Is that making sense? You can actually split it into two things. And luckily here, if you observe, when this line is rotating, see when this rod makes 90 degrees, the line AC also rotates 90 degrees, no? Both are actually same omega, but I can create a situation where this line AC will not rotate the same angle as this thing. Then you'll have omega 1 and omega 2. You're getting the problem there? So let me show you with an example. We'll make it clear. So end of the day, you can actually write this is the kinetic energy for pure rotation. Then this can be eventually written as kinetic energy of the rotation of center of mass. So it's not translation. Huh? The center of mass is going in a circle. You're treating it like a particle going in a circle. So kinetic energy of center of mass. So it kind of looks like that. Kinetic energy about center of mass. Clear with this? So this was the example I gave you before, and that time, right? I think we did some mistake. Let's do it again. So let's say we have a disk here, M1, R1. This was a JEE question also. And if there's a disk here. Okay, that is a hinge and it is free to move. So let me ask you this thing simply. Okay, this is let's say M2, R2. And let's say only this guy is rotating with omega 1 and let's say omega 2 is 0. What will be the kinetic energy of the system? If this rotate, how will that rod go exactly? Let's put a point here, okay, A and B. Just look at this line AB when it rotates. When the disk comes here, how is the line AB? A will be here and B will be here. Agreed? No matter how much you rotate, that line AB will remain same. If you see the top view, look at the top view, okay? This is the big disk. This is the black wala disk. Now, if you look at the line AB, it always looks like this. This is A, this is B, this is A, this is B, this is A, this is B. Isn't that how the path will be? And if you actually join all the point A will be going in this circle. If you join all the points B will be going in this circle. They're going in two different circles and they're always equal and parallel paths. Are you able to see that trajectory there? So the thing is doing what exactly? There is no rotation, right? The whole disk has no rotation. It has only pure translation. Is that making sense? So this disk is going in pure translation. There is no rotation. If you just hinge it. Sure with this? So what will be the kinetic energy of this system then? The kinetic energy of this system will be the big disk energy of I1 omega 1 square. Okay, ignore that. That is anyway fine. Now for this disk, what will we write? half m2, the velocity of the center of mass square, because it's pure translation. Making sense? There is no rotational component. Sure with this, right? If omega 2 was 0, if omega 2 also exists, now we have one more rotation, isn't it? Then that would have been half I2 omega 2 square. This is clear. First of all, let's keep omega 2 0. This is fine. Got it? Now, same scenario. Let me give it another way. Let's say this time it is not hinged, this time it is welded, fixed basically. अभी कैसे rotate करेगा? Now how will the points be? This will be A and this will be B. Make sense? So can I think of the scenario like this? So first the disk A and B. So I will assume like this. I will think like this. The center of mass has traveled here. So when it travels there, AB will remain same. So this is the motion of center of mass. And then I will think about this line, you're rotating with omega, and because of this, now because of this rotation, the line became A and B. So first you translate, then you rotate. Can I say this? So translation के लिए energy will be half m v center of mass square. Rotation के लिए energy will be half I com omega square. Is that clear, everyone? But we also know this is pure rotation. So if you actually look at that energy, right, if you add them up, see what you get. So this is there. So this half m will be nothing but whatever is that distance there, r1 omega square plus half I com omega square. This is nothing but half I hinge omega square. Are you clear with this? So there are two ways you can find the energy. So I don't want to confuse you, but it all depends on how you want to see this. So the question comes, do you want to see this as pure rotation, or you want to see this as one translation and one rotation? Is that making sense? So in this question, when it is welded, it is pretty clear. Every point is covering same angle. So it is pure rotation. So I can directly take I about the central axis and omega 1 square and done. हो गया आंसर एक स्टेप में आ जाएगा. Are you clear with this? But if that disk also now starts rotating, then we have a problem. It's not pure rotation about the center, right? So let me show the third case also. So if it is not welded, but it is going with omega 2. Again, I'll do the same story. First, I will do the translation. So when it does the translation, so it goes like this. So this is your translation. So remember, it is free to move, okay? So AB will be AB only. So this would be half m2. The center of mass ka speed will be r1 omega 1 ka square. Make sense? But now this is rotating with what exactly? This is rotating with omega 2, right? Look at this thing. If it was only hinged without rotation, what would have happened? You would have got only this term, no? There was no second term. But because it is rotating with omega 2, so the line now, AB line will not be any more straight. It will be in some other weird angle. So this line AB will be something like this. It will not be exactly in sync because of this omega 2. And this energy will be half m2 r2 square by 2 omega 2 square. Are you clear with this? So then you rotate it. And the big disk energy will be half m1 r1 square by 2 omega 1 square. There, if you, this is the kinetic energy of the big one. Add them up and you're done. Clear with this? So I think remember this. This is better. Getting it? So remember one method. This is better, right? So if you're sure, right, everything is welded, kabhi problem nahi aayega. Problem kab aayega? When you're hinging and you're making it rotate. I'll give you one more example. There was a question like this, which is also asked in a JEE, right? Usme there was a ring like this, and it was rotating. Now, we will do the same question which you have done before. Ye question yaad hai? The disk was rotating. So let's keep it simple, okay? Let's say light rod, length L, this is mass M and radius R, and this is rotating with omega 1, okay? Now, if I ask you find the kinetic energy of the disk, what will you rate? There is no rotation, okay? This omega 2 is 0. So there are two ways. That's what I'm saying. It all depends on how you want to see. If it is me, right, what I will do, I will say, okay, every point is going in pure rotation. So I will say this is pure rotation. And I will simply say half I hinge omega square. So if I want to find half I hinge, I have to find parallaxes theorem. That would be half mr square by 4 plus ml square omega square. Clear? I will say pure rotation. I'll write this answer. Now, you can also say like this. This was actually a question as a paragraph in, I think, JEE 2012 or 13. Not exactly this, but idea wahi tha. So imagine like this. Now we have the disk. Think of this way. For simplicity, let's call this side is A and this side is B. Okay. So first I will do translation. So first I will do translation. Now, when I do translation, the disk will come here, agreed, but can someone tell me how will A and B look like? A will still be this side and B will be still this side, agreed? Look at the arrow here. If I draw an arrow from A to B, that arrow ka direction cannot change. This is your translation. Are you guys able to visualize that? Look into my screen. I'll show you how it would look. Think of like, this is not dark enough. I need something. Look at my bottle here. Can you see this bottle here? This is the front cap, right? So let's say if I'm putting hinge in the center. So this is free to rotate about this line. Now see, if I put a hinge here and if I rotate, you can see the bottle will always keep looking at you. This will always rotate, okay? Every time I move my hand, the bottle is always facing you. But if I fix it up with a bolt, okay? Now when I rotate, can you see this bottle is facing away from you now? So this will be always facing outside if it is fixed in the middle. But if it is free to move, no matter how much I move, see the moment I move, the bottle will always keep looking at you. Best example, think of a giant wheel. Giant wheel mein cabins are there. They're hinged, right? When the giant wheel is rotating, how is the cabin always? If you're sitting in a giant wheel, do you become like this when you go up? How do you sit? You're always sitting in a vertical direction, isn't it? So when you're sitting in a giant wheel, the motion of the person is a translation motion. If you're standing in the giant wheel and when it is rotating, you're always standing vertical, isn't it? Kuch bhi karo, you're always standing vertical. Is that making sense? So this is translation, but remember, you have to rotate it back. So I will rotate about this direction. When I do this, then the disk will again flip. Then A will come inside and B will come here. So there is a translation plus rotation about center of mass. Again, you see which one you're confident. So this can be written as half m v square, which is L omega whole square, plus this would be half mr square by 4 omega square. Same answer. Is that making sense? The second one will be very good when, अभी देखो यहाँ पे क्या हो रहा है, when you are rotating now, this line AB and this line AB is rotating exactly 180 degrees. What if it doesn't rotate 180 degrees and rotates only 90 degrees? Then what will you do? Then both will not have same omega, no? Then this term will be omega by 2 whole square, isn't it? Means it is partially fixed and partially hinged. Problem समझ में आ रहा है? Imagine if that AB doesn't rotate completely, मतलब picture ऐसा हो जाएगा, let's say. So this was the disk. Let's say this was A and this was B, right? When this thing rotates this side, the disk will become something like, it becomes like this. It becomes flattish. It doesn't come face to face. If I try to see the top view, ना ऐसा दिखेगा देखो. This was AB. When the disk comes here, for some reason, this is AB. Means what is happening? The disk was rotating omega by 2, but the rod is rotating with omega, isn't it? They have different omegas now. Is that making sense? So there, this is an alternative. So if you ask me, right, when to use when, if you have everything fixed, there is no hinge, no bolt, nothing, welded and all, it is fixed. Use this thing, life is better. Half I hinge omega square, done. Right? They put a hinge, they put a bolt, and it starts rotating. These are the best examples. You know, this one, right? This wheel wala one. These kind of questions, right? Take it as a rotation about the center of mass and then rotation about it. So the only confusion there will be, you have to be careful when you're rotating, how are the angles and everything changing. Sure with this? So what I will do, right? Maybe in the next class, on the next class sometime, right? I'll keep popping up one question like this randomly. So maybe I'll give you in the middle of the session sometime, I'll give you 3-4 questions like this, just to see how much you remember. I think that should make things clear. Clear? I'll do one thing. I'll put a question up here. You can try this. Try both the ways, okay? When you try both the ways, you'll actually understand when to use when. But if you're getting confused, you're thinking, oh, what the hell? Just stick to the second one. Right, so this is that same error question. I told you this before. I think I forgot to save it here. This will take time to refresh. I'll post it. Okay, that was one. Okay, translation and rotation. Just go through that again, right? Because you can ask this problem in SHM, you can ask this in rotational mechanics. So 2 ways you can play around. The next thing, pseudo force. Now, pseudo force and centrifugal force, they're not same. Getting it? So let's talk about that. First of all, I taught you last time, but let me explain you this. So something is going in a circle. These are polar coordinates. This is theta. This vector is your r cap. It's your radial vector. This direction is theta cap, which is your tangential vector. This will be useful later on when we do work power energy, and when we do magnetism, we will need this polar coordinates. So we can see r cap, unit vector, which is simply cos theta I cap plus sine theta j cap. Right? So now when you differentiate this, dr cap by dt, that would be minus sine theta I cap plus cos theta j cap, and this will be d theta by dt. And if you see this direction, this is actually theta cap. You can clearly see this thing. This will be 90 minus theta. That will be minus cos theta I cap sine theta j cap. So this will be omega into theta cap. So whenever you differentiate a radial vector dr cap by dt, we get omega theta cap. So the vector rotates by 90 degrees and gets omega. What if I differentiate? So theta cap is minus sine theta cap plus cos theta j cap. If you differentiate this d theta cap by dt, you end up with minus omega r cap. So every time you differentiate this unit vector, it keeps rotating by 90 degrees and gets multiplied by omega. Clear with this? This is the first thing we need to know. Unit vectors, when you differentiate, they rotate by 90, polar coordinates basically. Now, even though in circular motion, right, we keep saying circle, circle, in reality, everything need not go in a circle. So if you take any particular point here, so this vector r bar will be the magnitude r into r cap. So this is the r into, that is your magnitude r and r cap. Now, if you differentiate this, dr by dt, this should give you velocity. This will be dr by dt into r cap plus r into dr cap by dt. So if you're going in some random path, two things can happen, isn't it? You can change the length of the vector and you can change the direction of the vector. So r is a variable, r cap is also a variable. When you're going in a circle, r used to be constant, isn't it? You never had a problem. But just now we saw what is dr cap by dt. Dr cap by dt is omega theta cap. So this is dr by dt. This is the radial velocity. This is the velocity along the r omega theta cap. So this is your v radial. So this tells you how the length of the vector is changing. This tells you how the direction changes, v tangential. In uniform circular, in circular motion, dr by dt used to be 0. Clear with this? Now, if I differentiate this again, I should get acceleration. Now, when you differentiate this again, dv by dt, right, you get something pretty big. We get a d square r by dt square r cap plus dr by dt r cap plus, now you're differentiating r omega theta cap. All three are variables. Dr by dt omega theta cap plus r into d omega by dt theta cap plus r into omega d theta cap by dt. And then d square r by dt square. And what is dr by dt? Dr by dt just now we saw, which is omega theta cap. No, dr by dt. I wrote something wrong here. Dr cap by dt into dr by dt. I know it looks big, but let's say the end of my result will pop up neatly. This would be your r alpha d omega by dt theta cap, and this would be r omega. What is d theta cap dt? Omega r. If you bring all the terms together, you get d square r by dt square minus omega square r cap plus r alpha plus 2 times dr by dt omega theta cap. So when a body is actually moving, it has 4 accelerations. It has 4 accelerations. But when you're going in a circular motion, dr by dt was 0. This term became 0 and this term became 0. This became your centripetal acceleration. This became your tangential acceleration. So those 2 terms got ignored because you took a uniform circular motion. But if your radius also changes, it gets messed up. So this is your linear acceleration. Right, along r bar. This is your centripetal acceleration. So there are 2 different things. This is your tangential acceleration, or it's actually called Euler's acceleration. This quantity, right, is called Coriolis acceleration. There was a question in 2018, I guess. 17, I don't remember. But luckily they gave you the formula. They will not expect you to derive this, but if you know beforehand, it is better. This combined term is called tangential acceleration. This combined term is called radial acceleration. So there are actually 4 accelerations when a body is moving. Now, what is pseudo force? When an observer is standing in a non-inertial frame, the mass into negative of acceleration of the observer will give you the pseudo force, isn't it? So if this is an observer, and what will be the pseudo force? Minus m into this one, we actually get 4 pseudo forces. The pseudo force was m into minus a bar. So we get, so when someone asks you, find the pseudo force, we have m into, I'll just put r double dot, that's a d square r by dt. I'll write it down better. R cap plus m omega square r cap. See, this became plus, that's your centrifugal force. mr alpha theta cap 2mv radial omega theta cap. This is your pseudo force due to the linear motion. This is your centrifugal force. This is your Euler's force. This is your Coriolis force. So by chance, if anyone asks you find the pseudo force, you actually have to find all the 4. So we will do some questions on this when I teach you circular motion, but the concept, right, you'll have at least some time to go over it. I want you to derive the whole thing on your own. That way you will remember. Okay? Now, if someone asks you what is the question, but let me show you 1 or 2 questions how they can frame on this. So if they ask you what is the centrifugal force, it's m omega square. Now think about this. In uniform circular motion, this was 0, this was 0, this was 0. Uniform circular motion. So this is the only centrifugal force, right, which also became the pseudo force. Clear with this? So let me ask you a question. Say, let's do this one. If you got this, you understood basic idea what is pseudo force and this thing. Standard question. We have a big disk rotating in a thing. We have a coin here, which is not slipping. This distance is smaller. Friction is there, everything is there, and this thing is rotating with omega. I have one person standing here. Let's call him A. Let's call him here. There is one person on the ground, okay, A. Person B standing in the center. Person C standing in this corner. And this radius is capital R. And person D is standing on this side. You're getting where it is? 90 degrees. So these are the 4 people who are standing and who are looking at the coin. And the coin is not slipping. So if I ask you, find the centrifugal force as seen by the 4 people, what will you say? Find the centrifugal force and find the pseudo force. As seen by the 4 observers. Each person will say something else. What do you guys think? I'll show you this formula again. So luckily here, right, these 2 terms are not there. There is no radial velocity. The coin is not moving radially. There is no alpha. So these 2 terms are gone. We are just playing with these 2. I'll bring those 2 terms also later on, but not now. You got the idea, right? A is the easiest one, isn't it? If you ask A what is happening, what will A say? A will say, I am at rest. So he is in an inertial frame. So what is the pseudo force? Zero. Clear? And there's no centrifugal force. Everything is zero for him. Understand, the centrifugal force and the pseudo force will come because the observer is moving with an acceleration, and that's why you have to put a pseudo force, not because the object is moving. I hope you're clear. The pseudo force comes because of the acceleration of the observer, not because of the object. Great. What do you think B will say? Remember, B is not at rest. Even though he's standing on the center, B himself is rotating, right? His head is rotating now. B is at the center. He's not moving front and back, but at the same place he's rotating. His eyes are rotating. So if you ask him, how will he draw the free body diagram? This is the FBD normally which we draw every time without actually thinking. We always keep the observer at the center and we solve the problem. Meaning we never bothered before, because at that point, right, you're in 11th, it gets really confusing. Now I can confuse you a bit. So if I ask you to draw the free body diagram, look at the forces: friction, normal reaction, mg. Now this guy will say, okay, I am rotating. So I am a rotating frame. So there will be a centrifugal force, which is m omega square r. Right? Do you have any other linear acceleration? This guy is not going front and back. So this is also the pseudo force. So we never had a problem here. And then you know how to solve the question. And then we'll say F is equal to m omega square r and less than equal to mu mg. And then we get omega from there. Right? Let's ask C to solve the problem. So C is standing here. C will say, okay, friction, N and mg, all that is the same stuff. So this is what he will write. He will say, okay, there is a centrifugal force. Again, remember what is the centrifugal force? M omega square r. R is the position vector from the object to the observer. So here the centrifugal force will be m omega square r plus small r. This is your centrifugal force. Centrifugal force is simply m omega square r, distance between the object and the observer. Clear? But this guy, because he's going in a circle, he himself has an acceleration, which is omega square capital R. Because of this acceleration, you will get one more pseudo force, which is m into acceleration of c. This is that linear pseudo force or that radial pseudo force. Right? Now, if you ask him to solve the question, he will say, okay, F m into AC, which is m omega square r, minus m omega square r plus r is equal to 0. Did you see? Answer is still same. You get the same thing. So what is the pseudo force here? The pseudo force is combination of everything, which is m omega square small r. The centrifugal force will change. This is the translational pseudo force. The total pseudo force is the sum of these two, which is still m omega square small r. Is that making sense? Can you try for D? I'll give you a minute. If you stand at D and solve the problem, how will the forces look like? So remember, there'll be two pseudo forces, one because of rotation and one because of my own acceleration in the radial direction. Top view, D is standing here. So friction will be towards center. How is the centrifugal force? M omega square R, where R is the distance between the object and the observer. So if I take this distance to be D, this will be M omega square D. This is your centrifugal force. Clear? But because you're going in a circle, you yourself have an acceleration, which is omega square R. So because of this, we have to put another pseudo force. I'll just maybe use green only. M omega square, this is MAD, mass into opposite direction of the acceleration. M omega square capital R. This is your linear pseudo force or transition radial pseudo force. Right? And if you take this component is theta, this is theta. Now, if you look at the forces on the coin, we have friction. This is M omega square D cos theta. This is M omega square D sine theta. This is M omega square capital R. But what is D cos theta? D cos theta is capital R, which is M omega square R. So this and this will get cancelled. And what is M omega square D sine theta? M omega square small r. So friction is equal to, again, M omega square small r less than equal to mu mg and solve. So what is the pseudo force again? The pseudo force, the net pseudo force is always M omega square r away from center. Is the concept clear? But one thing, when you're solving problems, itna mat socho. When we solve the problem, still everything that I taught you is always in the Beaker frame. We always stood in the center and we did. So centrifugal force, pseudo force, sub same hi tha. We never had a problem. But if you take this guy and start making him stand at different places, suddenly things will become a little weird. So M omega square D is R square plus, yeah, that one. So no matter where you stand, the net pseudo force will always come to be the same. The centrifugal force will keep changing. The linear pseudo force, radial pseudo force will keep changing. Radial matlab you're going in a circle towards the center, right? Your acceleration. How is this guy acceleration? This guy acceleration is toward the center. Right, Poroja? Think of this thing. Right? What is the acceleration of D? Towards the center? So when I ask you to do the pseudo force, what will you do? Mass into acceleration of D ka acceleration in the opposite direction, right? Maybe don't call it radial pseudo force if that's confusing. Just write it as linear pseudo force. Okay? Maybe the word radial is misleading you. Clear with this? So I'll just give you one homework thing you can try. Then we can talk about this in circular motion. Let's say we have a rod here which is rotating with omega. There is A here, there's B here. Let this be some R and this be L. Find velocity and acceleration of B as seen by A. Find the centrifugal force and the pseudo force of this is find the centrifugal force Pseudo force, centrifugal force. I forgot. I think find centrifugal force only, I guess. On B as seen by. I can ask you pseudo force also. Yeah. Try this next class discuss करते हैं. We'll start the test now. But go through today's class. I would say derive everything on your own. When I go through circular motion, again, I will brief it up once. I want you to get this concept ready by circular motion, because then we will do maybe 2 to 3 problems on this. So there are 4 accelerations there. And the translation and the rotational thing, make sure to go through that. I will give you a problem also on that. So maybe you can try. Let's see. I hope it got loaded by now. It's not getting updated here. It will take time. But it is actually the Irido question I showed you before. No props. Okay, let's start off the test. You guys need a 5-minute break. Take a 5-minute break then. Maybe थोड़ा late हो जाएगा. We can start off. Take a 5-minute break. We'll start at 9:45. Be there. Be online. Don't go away.